In this lesson, we're going to continue to flesh out the concept of hybridization. So we already talked in part two about a few important concepts, but we left off with this example here, being able to determine the hybridization of each atom in a molecule. And so this is going to be high yield. It will appear very likely on your first midterm and essentially will disappear from there on out. Why? Because it will be expected or implied knowledge. So this is easy points to get down and make sure that you understand. We're going to do one more example before we move on to another slightly related concept. And so, example, say this is 2, and we'll keep that one as the first one. And so we have right? So this is the molecule ahead of us, essentially. And so we need to go through every atom and determine what the hybridization of it is. So this carbon we'll put in blue has 4 bonds around it. Anytime I have 4 single bonds, I'm going to have sp3 hybridization. Let's take a look at this nitrogen. We'll put it in green. Whenever I have 3 bonds around it, and essentially one of them being a double bond, so 3 total domains, I'm going to have sp2 hybridization. Now, we look at this nitrogen here in the middle. It has a double bond around it. So usually when things have a double bond, we're going to have sp2 hybridization. But this actually has 2 pairs of double bonds. And so this is going to be sp hybridization. So this is a trap to watch out for. Usually we look for things with triple bond that have sp hybridization because that means, sp hybridization, right? So whenever we have a triple bond, those atoms are going to have sp hybridization. And so, again, this is tricky because it has 2 double bonds. Whenever an atom has 2 double bonds around it, it's going to have sp hybridization. Now, lastly, we have a nitrogen on the very tail end. It has how many electron domains? 1, 2, 3 total. Whenever we have 3 electron domains, we're going to have sp2 hybridization. Hopefully, this helps you recognize this trap of having 2 double bonds on a single atom being sp. So we look for triple bonds and we look for 2 double bonds on an atom. Those have sp hybridization. So those are the things that we're going to watch out for. Now let's delve into the concept of sp or S character. So whenever we have something that's sp3 hybridized, we mixed all the orbitals together and we get s plus p plus p plus p, right? And so when we look at the s orbital relative to all of the other orbitals, we basically have 1s divided by 1s plus 3p, so a total of 4. So 1 divided by 4 is going to be 25%. So we would say we have 25% S character. There are 4 orbitals total. The s orbital is 1 of 4, and so 1 of 4 is 25%. So now let's take a look. Let's see here. Let me clear this up a little bit so it's not confusing. So 1 out of 4, 4 orbitals total. 1 of them is s, so 1 divided by 4 is 25%. So now let's take a look at sp2. We have 1 s and 2 p orbitals. So we have a total of 3 orbitals. One of them is s, and then 2 times p, right? So a total of 3, and then s is 1 of that 3. And so that leaves us 33% S character. And then lastly, SP. You can start to guess. We have one s orbital and one p orbital. So two orbitals total. So s is going to be one of two, and so 1 divided by 2 is going to equal 55% s character in an sp hybridized orbital. Now, this isn't exactly high yield. You'll probably see maybe one question on this, but it's not a concept that we emphasize too heavily. It's just important that you understand that sp hybridized orbital has a 55% s character, and then a sp2 hybridized orbital has a 33% s character, and then a sp3 hybridized orbital has a 25% s character. And so this is important to know. But it's not going to necessarily be a high yield concept, right? And so we continue to move on, and now we'll talk about another incredibly high yield concept, and that is drawing atoms and their hybrid orbitals. And so let's go to an example that we've kind of already done. So this is example 3. And let me give myself some space here. And so we have essentially CH4. We know CH4's geometry is going to be sp3. And so these lines right here are going to be in plane. So this and this are in plane. Right? And then anything that is dashed is going towards the back. So imagine it going into the page. And anything that is wedged is coming out at you. So wedged equals, we'll say, going towards the front. So imagine again, it's coming out at you. And so this is the the molecule CH4. And so now we want to draw it with its hybrid orbitals. We said that anytime something has a 4 single bonds around it, it's going to have sp3 hybridization. So let's start drawing carbon.